Hello everyone. In this video we're going to try to find the equation of this sinusoid that's depicted here, and in order to be able to do that we need to understand the standard cycles of sine and cosine as well as their reflections with respect to their baselines, meaning negative sine x and negative cosine x. When it comes to the sine function, notice that one standard cycle of sine starts at the origin, then goes to a max point, then goes to the baseline, then to a low point or min point, and then back to the baseline. Sine will do a different thing. It'll start at the baseline, and negative sine will start at the baseline, go to a min point, then to the baseline, to a max point, back to the baseline. For cosine, cosine starts at a max point. The standard cycle of cosine starts at a max point, then goes to the baseline, then to the min point, then back to the baseline, and finally to a max point over one cycle from 0 to 2 pi in both cases. So considering what we just saw, if you look at this, you can see this is a negative cosine type of sinusoid. So in order to be able to write it, we need to go to our standard form and figure out what each of the letters are going to be. The standard form, if you recall, was y equals a plus b cosine of c times x minus d. Now a here is the baseline, which we can see in this graph. It's the same as the baselines for these two graphs, which is basically the x-axis, which is also known as y equals 0. So we know that the baseline is 0. B, well, the absolute value of B actually is the amplitude. C is 2 pi over the period, and D is the phase shift, the horizontal phase shift. Now I'm giving you a much more general than this just a sine bx and a cosine bx, because it's much easier to understand it if you know what each of those letters stand for. Now in this case we can see that this graph goes, it appears that each of these tick marks represents 1 point, 1, 2, 3, 4, 5, 6 below the x-axis, and 1, 2, 3, 4, 5, 6 above. But the units are each 1 unit, but this graph goes 1, 2, 3, 4 below and 4 above. So we know that the amplitude is going to be 4. But we also know that this is a negative cosine curve. So when we write our equation, we're going to use the negative sign in this case as well. Now C is going to be the period. Now we know that the cosine curve covers one full cycle in a period of 2 pi. So this is not showing us a full cosine curve. It's only showing us half of one full cycle. So this one is covering half of a full cycle in 2 pi. So we know it's going to cover the entire full cycle in 4 pi. So the period of this function is going to be 4 pi. So when we want to find this constant c, we're going to go ahead and divide 2 pi by 4 pi, and we end up with 1/2. So that's where we know this constant is going to come from. And D tells you how far shifted it is relative to the regular negative cosine curve, and we can see it is not shifted at all. So D here is going to be 0. Now we have all the information that we need to go ahead and write the equation of this sinusoid. It's going to be y equals 0 because of the reflection minus the amplitude, which is 4, and then cosine of we need c, which is 1/2 times x minus 0. Of course, if we simplify this, we end up with just y equals -4 cosine 1/2 x. And that's how we figure out the equation of a sinusoid such as the one given in this graph. So be safe until our next video.